Good afternoon, I am the expert Sergey Somov. In previous videos, we examined flat-field microscopes, biological upright and inverted microscopes. Today, I will talk about the MAGUS Stereo 90 stereoscopic microscope. A stereomicroscope is an optical device for obtaining magnified images of volumetric objects while preserving three-dimensional perception. The volumetric magnified image of the object with high contrast and depth of field allows for micromanipulations in a comfortable working space. This involves restoration and quality control, soldering and gluing small objects, and assembling watches or electronic devices. Let's figure out what makes the image three-dimensional in these microscopes. The objective forms the magnified image of the object. The eyepiece only magnifies the image created by the objective. Therefore, it is the objective part of the microscope that is responsible for the three-dimensional observation of the object. In the flat-field microscopes that we discussed earlier, a single objective forms an enlarged image of the object. The prism of the binocular visual attachment duplicates this image, while the eyepiece magnifies it. As a result, in both eyepieces, we observe identical images of the object formed by a single objective. The stereomicroscope forms an image differently. The objective part creates an enlarged image of the object from two sides at a stereoscopic angle of 11 or 15 degrees. Different images enter the eyepieces, with each eyepiece magnifying its own. As a result, we obtain two different images of the object in the left and right eyepieces. This method preserves the virtual volumetric nature of the object and the clarity of the surface relief. There are two optical schemes that implement observation at an angle. The first is the Common Main Objective, CMO scheme. In English literature, CMO stands for Common Main Objective. Other names include the Abbe scheme or the Galileo scheme. The second is the Grignou scheme with two objectives positioned at an angle. Today, we will not compare these two schemes, but will move on to the specific model, MAGUS Stereo 90. The microscope uses the Grignou optical scheme, which provides a high depth of field and good image volumetricity due to a stereoscopic angle of 15 degrees. The large working distance is convenient for manipulating objects, which is why the microscope is used for restoration, soldering, assembly, quality control, and other similar operations. Now let us turn our attention to the design features of microscopes. The optical head combines a trinocular visual attachment and a pancreatic objective into a single unit. Perhaps the most important part of the microscope is the objective, so let's start with that. The magnification of the pancreatic objective smoothly varies from 0.7 to 6.3 times without loss of quality and maintains a working distance of 110 mm. Both figures are quite high, so the technical specifications of the lens favorably distinguish the MAGUS Stereo 90 against similar microscopes. The magnification of the microscope is adjusted by rotating this knob. The numbers on the handle indicate the magnification of the objective. The magnification of the microscope in the basic configuration ranges from 7 to 63 times. When using additional attachments on the objective, either 0.5x or 2x, the working distance, magnification of the microscope, and field of view are altered. The eyepiece tubes of the visual attachment are equipped with eyepieces. The tubes are adjusted according to the observer's interpupillary distance, ranging from 53 to 75 mm. The eyepieces with 10x magnification have a linear field of view of 22 mm and a long eye relief for comfortable use with glasses. Each eyepiece has a diopter adjustment. The eyepieces are securely fastened in the tubes with screws. This mounting protects against accidental dislodging of the eyepieces when moving the microscope. The microscope can be equipped with eyepieces of different magnifications, 15x, 20x, and 25x, as well as a 10x eyepiece with a scale. When changing eyepieces, the magnification of the microscope and the field of view are altered. The working distance remains unchanged when switching eyepieces. The digital camera is installed in a vertical tube with a visualization channel. A single C-mount adapter for mounting the camera is included with the microscope. The camera outputs the image to a computer screen or television. The knob on the rear surface of the optical head switches the light beam to the visualization channel. In one position of the handle, the light is directed to the eyepieces, and in another position it is directed to the third channel. The optical head is mounted in a ring of the bracket and secured with a screw. The head can rotate and be fixed in any convenient position. The bracket is attached to the focusing mechanism. The focusing mechanism moves within the stand. The focusing range is 83 meters. The coarse and fine focus knobs are located on both sides of the stand. When working at magnifications above 40x, you will appreciate the convenience of using the fine focus. The stiffness of the focusing mechanism is pre-adjusted by the manufacturer. With the correctly adjusted stiffness, the body of the optical head does not lower under its own weight. If you need to adjust the stiffness of the focusing mechanism, use this ring. Turning counterclockwise decreases stiffness. Turning clockwise increases it. Adjust the mechanism to suit yourself, but remember that excessive tension can affect your comfort while working. At the base of the microscope is the power supply and a source of transmitted light, which is an LED. The base also serves as a stage. The object of study is placed on a plate that is installed in the socket of the base. The diameter of the plate is 90 millimeters. The set includes 3 plates. The black and white plate is used for contrast. Light objects are examined on a black background, while dark objects are examined on a white background. The white matte plate diffuses light for even illumination of the plane of the examined transparent object. The transparent one is used when maximum brightness of the transmitted light is needed. If necessary, the object can be fixed with 2 clamps. To study opaque objects, we use a reflected light illuminator. The standard equipment includes an oblique illumination illuminator, which is fixed in a bracket. The illuminator's plug is installed in the tripod socket. The power supply is built into the base. Additional illuminators are available, which connect to the AC power supply through independent power units, regardless of the microscope. Ring illuminators are fixed to the objective part of the microscope with 3 screws. The ring illuminator provides shadow-free lighting. The illuminator with a polarizing filter eliminates glare from highly reflective surfaces. The sector switching illuminator simulates oblique lighting from the desired side. A gooseneck type point illuminator is also available, which adjusts the lighting at the required angle and provides the necessary light and shadow for the study. In conclusion, the main features of the MAGUS Stereo 9T stereoscopic microscope are as follows. A zoom mechanism for smooth magnification changes without loss of focus. Magnification ratio of 9:1. Trinocular head with 360-degree rotation and vertical tube for mounting a digital camera. Advantages of the Grinu optical scheme. High depth of field, good volumetric quality, compact design, and low price. LED illuminators for transmitted and reflected light with a long service life. A wide range of compatible additional accessories. In our demo room, you can also view other models of stereoscopic microscopes. Perhaps you do not need such a high zoom ratio, and you will choose the budget model MAGUS Stereo 7B. Or perhaps, on the contrary, you might be interested in an Abe system research class microscope with a magnification factor of 18:1, and you will choose the MAGUS Stereo A18T. Come to our demo room, bring your samples, compare models, and choose the one that suits you best. We will help you select additional accessories and a camera. See you soon.